Welcome to this session about Spring Framework 5.1. This is quite a technical deep dive, even if it's mostly concerned with design topics. And it's very much a core framework perspective that we're taking here. So in contrast to the session by Sebastian Deleuze about Spring Kotlin and everything that we do with it, this is rather a very focused core framework 5.1. What do we do in 5.0 and 5.1 with the JDK 8 baseline? How do we go about JDK 9, 10, in particular 11 support? What role can the module system play in this? What kind of upgrade advice do we have? Very much focused on that story. Many of the things outlined here do shine through, of course, to Spring Boot, 2.0, 2.1 in particular. So it's a very immediate applicability in boot applications as well. But the perspective that we're taking for these next 50 minutes is very much the core framework itself. So this is, of course, also my personal role in all of this. I'm responsible for leading the Spring Framework open source project. The Spring Framework and the Spring Boot teams are very close. So it sometimes feels like we share as many people as we have individual dedicated roles on those teams, between the teams. So we are closely collaborating, of course, with Boot 2.1 and also for our next iteration, Spring Framework 5.2 and Boot 2.2. So there might be the occasional connection to Boot that we're outlining here. All right. So the primary motivation for Spring Framework 5, the 5 declaration, is always a baseline upgrade and, of course, new feature themes. In this particular talk, we're going to spend pretty much the first half on the JDK 8 foundation, which is a very important enabler for many things, for a lot of goodness that we can do in the core framework. And pretty much the second half is going to be about the JDK 11, the kind of beyond JDK 8 topic and the way we deal with it, what you can do with it from a Spring perspective. In terms of what we're not covering today here, we're not going to talk about the reactive stacks. Sebastian has already touched upon it. There's going to be a dedicated going reactive with Spring Boot session by Mark Heckler tomorrow, which are like around 1 p.m. tomorrow, which I highly recommend if you're primarily interested in the reactive stack options. And for our purposes today, this is kind of more of a side topic. We're more API design-centric here. All right, so the JDK 8 foundation. Of course, JDK 8 is not a kind of new topic in the Spring space, not at all. Just to remind you, Spring Framework 4.0 even introduced JDK 8 support in late 2013, 3 months before JDK 8 went GA. By the Spring Framework 4.3 iteration here, this is very well baked. There's rich Java 8 development support all across the board in Spring Framework 4 and then in Spring Boot 1.5 on top of it. But the frameworks underneath are actually Java 6 based, Java 7 oriented to some degree. The Java 8 support is basically an optional runtime affair. We of course, have some experience in doing this with previous JDK generations. So if you're using Spring Framework 4.3 on Java 8, it hopefully feels like a Java 8 oriented, even Java 8-based framework to you in many ways already, so that you don't even notice that it's internally not Java 8-based. And Spring Framework 4 also used the opportunity to anticipate a lot of impact from JDK 8 in terms of API design conventions, functional interfaces. We knew that we couldn't quite use them right now in kind of our hard APIs, but we knew that this was coming. So in many ways, Spring Framework 4.3 is already prepared, right? Or that already has preparation steps in it on its way to Spring Framework 5, where Java 8 is the foundation and a hard requirement across the framework now. So while we can support almost everything you're using from Java 8 in your code, if you're running on Spring Framework 4, you can use completable future, Java.time types, whatever. We know how to adapt them at runtime. You don't even notice. But we couldn't use them internally, not in the core code base. No lambdas, no method references. In particular, no Java 8 specific API types in the core code base itself within the framework. So the point that we were waiting for is roughly this one. That's a survey from about a year ago. We were waiting for the point where Java 8 is so established in the industry that we could ship a framework generation and a Spring Boot generation with a hard requirement on Java 8. And well, about a year ago, we already saw like about 75% of people using Java 8 out there in industry surveys that are usually quite indicative of the real world. Very little Java 6 use, quite a bit of Java 7, but fading out. Very little Java 9 use, of course, that was shortly after its release. So that was the point we were waiting for. And in Spring Framework 5, we took the opportunity to skip Java 7. So there's no Java 7 baseline Spring release, just a Java 8 baseline now. We jumped from a Java 6 to a Java 8 requirement. The entire framework code base is Java 8 based. And we really mean this. It's not just that it's being compiled with Java 8. We literally revisited the entire code base, touched almost every source file, and updated it for Java 8 conventions and a few further conventions that we were being added. But primarily the Java 8 upgrade. Internal use of lambdas, method references wherever we can. Internal use of collection streams where that makes sense. Internal use of some of the reflection enhancements. There's new reflection API variants, a refactored reflection API in Java 8 that we can use for both performance optimizations and just for streamlined code. So both for maintenance, but also with a bit of performance optimization behind it in the end. So it's not just lambdas and method references, it's primarily Java 8 API types that we can now rely on. Executable as a base type of constructor and method. Completable future, Java util concurrent enhancements, Java.time types like instance and duration, and in particular collection streams, and everything that comes with it, and not least of it all, the Java util function package and the Java util function interface types that are kind of shipped as common ground in Java 8 now. We can also make use of a particular Java 8 feature, default methods in interfaces. That's kind of the third major enabler. Across our code base, we have many interfaces in Spring. Spring is very interface-oriented, in particular in the framework design. And many of those interfaces can benefit from default methods. We couldn't use them before, Java 6.7 compatibility, but now with Java 8 in place, as a minimum requirement, we can declare default methods wherever we see fit. And we do so for two purposes. There's the common one, backwards compatibility. Whenever we're introducing new methods, we're trying to declare them as default methods so that existing implementers of those SPI interfaces, whatever they are not being broken. But there's also a degree of convenience that a kind of a convenience perspective that we are applying here. Existing interfaces with existing methods might just be a little simpler to implement if we declare some of the methods or even all of the methods in the interface as default methods. Take, for example, bean post processor or the handler interceptor types in Spring MVC. Several callback methods. You might only be interested in a particular one that you're implementing, and for the rest you're okay with a stubbed out default method. We used to have a pattern of adapter classes to derive from if you don't care for the other methods, shielding you from the other interface methods. But now, direct implementations of the interface can also be focused on just the method that you care about. So those are the fundamental enablers. Java 8 features that enable a revision in the core framework accordingly. In terms of Spring Framework 5 in general, it's not just the Java 8 upgrade, of course. There's a strong story about functional API design. But even that is Java 8 inspired. Because whenever we say functional, we actually mean functional as in Java util functional, as in Java 8 collection streams, as in Java 8 lambda expressions and method references. That kind of functional in Java's object-oriented context, of course. And for Spring Framework 5, we took a rather, well, a somewhat extreme perspective. We took a step back, quite literally, right? And revisited the entire framework, the core container, web endpoint registration, many parts of the framework, from the perspective of what if we wanted to use them purely programmatically, with Java 8 constructs in particular, no annotations in use, avoiding classpath scanning, even avoiding reflection to the degree possible. So it's a sort of black and white position. In practice, none of this is as black and white and as like everything we do in Spring, there's lots of shades of gray in between. You can combine annotation-based features with programmatic registration everywhere. But from a design perspective, it is really helpful for us as framework designers to look at the framework and to enforce that the framework can be used without any reflection assumptions, without any annotation-based assumptions. Fortunately, that is not as much of a challenge as it may sound, because the Spring framework actually predates annotations. So the early versions of Spring had programmatic support, metadata-based support with bean definition objects being registered and an XML parsing layer on top. These really old design conventions in Spring actually have their merit right now, because it means that the annotation-based layer was always an adaptation layer, which is really helpful now, where we are trying to expose a very programmatic perspective again. And fortunately, we do not have to fight any annotation-based assumptions in the core container at all. So the other inspiration, next to Java 8, is of course Kotlin. Kotlin as a language has many benefits, and of course in terms of practical use in Spring-based applications, that's primarily your call. For us as framework designers, we decided to give first-class love to Kotlin, right? We wanted to embrace Kotlin, not just tolerate it as a JVM language, but to really go the extra mile, to deliver an idiomatic Kotlin support story, and to take Kotlin as a source of inspiration. The inspiration primarily coming out of the language design and Kotlin's function model, Kotlin's own functional features. So what we did in Spring Framework 5 basically takes kind of the commonality and the best of Java 8 and Kotlin and leads to design conventions in the core container, actually across the framework, far beyond the core container, and delivering a Java 8 functional experience and a Kotlin functional experience, both of them in a very idiomatic form. One more topic to touch upon is briefly is null ability. In the course of this revision of literally the entire code base, we bumped into a good old Java problem again, that API definitions, methods in particular, do not declare whether their return type can be null, and they also do not declare whether incoming parameters to those methods can be null. So we kind of have to always assume that everything can be null, theoretically, right? And you're looking into the Java doc to find out whether that's actually the case. This can be good enough. We've kind of learned to live with it, but it is a deficiency we have in the expressiveness of Java for API definitions. And in Spring Framework 5, we decided to adopt null ability annotations, a non-null by default convention. So our packages declare non-null API, even non-null fields internally. So whenever there's no specific declaration, we assume a non-null role. Both for constructor parameters, method return values, and internally even for field definitions. If there's an exception to this rule, and there are plenty, of course, we add an add-nullable annotation. This is a common convention. There have been several attempts at shipping such annotations out there. There's unfortunately no proper consensus yet. We ship our own annotations here, meta-annotated with common annotations out there, so that common tools like IntelliJ IDEA and Eclipse detect them and understand them semantically. So if you look at a Spring Framework 5, the Spring Framework 5 versions of, say, JDBC template, Bean Factory, take any API type, right? Any class from the code base, really. You can look at it, and you have a formal null ability declaration in them. If the Bean Factory getBean method says nothing at all, basically non-null by default, then you will never get null out of it. And only if a method returns null, will return null only if it's annotated with add-nullable. The same applies to the parameter level for incoming parameter values. This is enormously useful for our own purposes. We validate the entire code base with the use of IntelliJ IDEA primarily, because that's what most of us are using. There's a particular interesting one that I'm highlighting here, the constant conditions and exceptions inspection. If IntelliJ IDEA is set up to understand the null ability annotations, it can infer hard consequences from it. It will warn you if you are trying to call something that can potentially be null, leading to a null pointer exception, but also the other way around. It will also warn you if you're defensively checking something, whether it is null or not, and it can actually never be null according to its definition. So this allowed us to, in our own code base, to revisit a lot of code, and in particular to streamline overly defensive code, and to provide a definition layer across the entire code base, both for the public APIs and even for more internal ones. We did it for every single source file, basically leading to a very maintainable affair. This is, to some degree, an internal effort. It does show up in the Java doc, and in this, if you're diving into the source from your application classes. So I highly recommend, whenever you're calling some Spring Framework APIs, I highly recommend looking at the Null Ability definition. And if you choose to use Null Ability definitions in your own code base, IntelliJ IDEA, for example, will be able to validate your code against the framework calls. If your code calls a JDBC template method, then IntelliJ IDEA knows that a particular return value from JDBC template query for map will never return null. And you can declare it accordingly in your code. So that's basically the Java story. An even stronger effect can be seen in Kotlin, because Kotlin, in its type system, has Null Ability as kind of a hard concept. You can have non-null declarations, non-null assignments in Kotlin, but the Kotlin compiler only accepts those when you're calling an API that says that it will never deliver null, never return null. So defensively, you can't do this with common APIs. With our revision in Spring Framework 5, from a Kotlin perspective, as a Kotlin user, you can now call Spring Framework APIs, and the Kotlin compiler understands the Null Ability definitions and will allow non-null assignments, non-null assignments wherever possible, wherever our APIs declare that they will never return null. So it's an enabler for idiomatic use of Kotlin's type system. This is a strong driver in its own right. All right, let's go a little bit back up. I'll give you a few examples, actually, of Null Ability as well, but it's actually the dependency injection space that we're talking about now for a moment. There's a new API, reasonably new API, called ObjectProvider. It's introduced in Spring Framework 4.3. You can get it through @AutoWire, the object provider of the target type you're interested in. And as of Spring Framework 5.1, there's also a programmatic equivalent. You can call the application context or the bean factory and say, get bean provider of the type I'm interested in, and then you get an object provider of that type. This is kind of a lazy, indirect reference to the bean of that type. So it's lazy in the sense of we are not enforcing the creation of an instance yet. And it can be a little indirect because you can also ask a few questions about it, right? It's not. It's a way to lazily obtain the instance just by calling getObject on it, but it's more sophisticated than this. ObjectProvider has in 4.3 methods like getIfAvailable, getIfUnique. By definition, those methods would check the container, return the instance if it's there. If it's not there, they would return null. That's the contract. So in Spring Framework 5, of course, those methods are now annotated as nullable. They have to be. Non-null by default, and we are enforcing the Null Ability definition here. But at the same time, we also introduced new methods, and as a fine example for what we did in other places as well. So ObjectProvider also has methods like getIfAvailable with a default supplier. That's a Java util function supplier. So you can basically say, I have an object provider of this foo class of mine, and give me the instance, the common primary instance in the container if it's there. If it's not there, then give me whatever that default supplier produces that I'm passing in here. Java util function supplier is, of course, typically used with lambdas or method references, so it's a reference to some default instance or default creation function. That method is not nullable. Right? So the point here is that getIfAvailable with the default supplier will never return null according to its definition. So it's, for example, from a Kotlin perspective, perfectly usable for a non-null assignment. Even slightly more functional, we have an ifAvailable consumer method, Java util function consumer in Java 8. So you're basically not expecting any return value. You're saying, if that instance is there, here's a consumer, typically a lambda expression, doing something with the object if it's there. Please call that consumer if it's there, otherwise skip that step. So that's functional API design for core dependency injection purposes in Spring Framework 5.1's core container. and a little bit of null ability thrown into it. In 5.1, there's actually a few more variants of using an object provider for completeness here. So aside from the individual methods, like getObject, getIfAvailable, and getIfUnique, we also have some streaming methods. Basically, what if there is more than one matching bean of type foo? And as of 5.1, you can use an object provider to iterate over those with a Java 5 for loop, because it's an iterable, or to use the stream API. You can say object provider stream, here's a few conditions, now turn it into a list, or let me for each them, whatever. So there's an immediate connection to Java util collection streams here as well. And streams, the regular stream is lazily resolvable. There's also a notion of a so-called ordered stream, which is not lazily resolved, because we can also only order instances as they have been retrieved already, but nevertheless provides a common stream API for those inspection purposes. So that's super useful. It's basically a modern-day programmatic version of injecting a list of foo, a more expressive version of dealing with several matching dependency types, beans of a particular dependency type in the container. Right, so that's the injection point perspective. Now, from a configuration perspective, this is the core version of functional bean registration. You might have seen in Sebastian's talk, you might have seen that there are high-level DSLs built on top of this in a particular Kotlin DSL. But at the core framework level, this is the essence of what this is about. You can take a Spring generic application context, register a bean of type foo with default conventions, or register a bean of type bar with what we call an instance supplier, a function to be called for obtaining a new instance of that particular component type. This is the standard generic application context. It's more than 10 years old as a class. And it's the same kind of component that can also register beans with a metadata object called bean definition. It's the base class of annotation config application context, which some of you might have seen already with its scan and register methods. But as of Spring Framework 5, this class has overloaded register bean methods for functional registration purposes. So those methods are actually new. They are variants of what was possible before, but they are much more expressive now. So this particular one, the example above, is basically registering a type with an instance supplier, in the bar version of it. The instance supplier is a lambda expression here. It's literally a Java util function supplier, and the container has a straight dispatch to it whenever it needs a new instance. So this is not like reflectively called at all. There's a straight code path in the core container saying, if this is a prototype bean, or a scoped bean, if I need a new instance of it, straight invoke dynamic dispatch to its constructor expressed here through a lambda expression. The version below is even slightly more sophisticated. If you look at the bar registration below, there's not just one instance, one lambda expression here. There's actually two. We register a bean of type bar. We say, like, whenever you need a new instance of bar, dear container, then please call this lambda expression here. That lambda expression builds a new bar, seems to call a constructor that takes an object provider of foo. Not really important, but possible, as indicated here. And it has another lambda expression, which we call bean definition customizers. There can be any number of those extra lines. You basically get a chance to modify the bean definition instance before it's registered. This is primarily there for setting flags, the primary flag, the lazy init flag for singletons, adding qualifiers, adding bean definition attributes, anything you can programmatically do. And in particular, many of those things can also be expressed in the XML and annotation-based models, so they are also very immediately accessible here. The life cycle is completely up to the container. So you're instructing the container with the rules of how to deal with those components. The life cycle itself, deciding when a new instance has to be created, in which order they are being created, when they are shut down, is completely up to the container, just like with other kinds of bean definition formats. Mixing and matching these things is easy, so you can also register other bean definitions. You can apply an XML reader to it, to the same context. You can start with annotation config application context, register a few beans, programmatically in this style and scan a certain package and combine the outcome into the same application context. Everything is possible. This is totally up to you. This is basically part of the core container toolbox. Just a little thing, the example below here, registering foo actually has a method reference, foo : new. This is the only example for a method reference here, Java 8 language feature, pointing straight to the constructor of foo. Just in case you're wondering why that is there, well, it's quite simple. It's technically avoiding reflection, because even instantiating a class with its default constructor is reflection. By providing an instance supplier that points to the default constructor of foo using a Java 8 method reference, we can do a straight invoke dynamic dispatch. To it, no need for reflection. If that was necessary, in practice, of course, reflection isn't all that bad, right? In particular for singleton beans, you're creating them on startup. But there are certain environments where you might not be allowed to use reflection on certain types or not at all. Think about Graal VM, Substrate VM, native images. If you intentionally design, handcraft a configuration arrangement for a particular like a minimal microservice arrangement maybe for a particular deployment technology where you know that reflection can be an issue, here are all the tools to avoid reflection completely. And last but not, well, not quite last, but almost last here in this storyline, we have the same examples in Kotlin. In all brevity here, this is basically the version above is very Java style. It looks almost like the corresponding Java code, instantiating a new generic application context, registering foo class with default conventions, registering bar with an instance supplier. It's noticeable here that this is more concise. It's simply more concise because the Kotlin language is more expressive. There's no need here to repeat yourself for information like the bar.class before, where you say it's bar.class and here's an instance supplier of bar. The reason why we need to do this here is because a Java 8 lambda or method reference does not have a reliable return type that can be inferred from it. Basically, from a framework perspective at runtime, we don't know what that inline lambda expression is producing. It could be any object. We don't know it's going to be a bar instance. In order for registering a bar with the container, you have to explicitly declare it, an extra argument bar.class and the instance supplier. In the Kotlin version, we are making use of the Kotlin function model. So what you're seeing here looks like the methods that we used before, but it's not actually the same methods. It's overloaded methods taking a K class and a K function. So foo.class is a K class, a Kotlin class, but that's a Kotlin reflection type. And the bar instance supply is a Kotlin function. And Kotlin functions have a reliable return type. They basically reify generics, sort of. They retain their return type declaration. So you don't need to explicitly say bar, and here's the instance supplier. Just the instance supplier, just the function is good enough. The version below is the same code rearranged, different Kotlin language style applied to the very same methods. I'm dubbing it Gradle style usage. It's not an official term. It feels like the Kotlin DSL and the Gradle build tool to some degree. That's why. Using Kotlin's generic type declaration syntax instead of class arguments in particular, which can be nice, in particular if you want to go for a more DSL-oriented experience. Now, how are we shipping this? This is part of the standard Spring Framework jars. So if you get Spring Framework 5.0, 5.1 from Maven Central, the standard Spring context chart that you get from there allows you to do this. We ship Kotlin extensions, like in this case, a generic application context extensions.kt file in our standard jars. The Kotlin compiler detects it by convention and knows that those are extension functions for that particular Java type. The Java compiler ignores it completely, but when you're using it with the Kotlin compiler, if you choose to use Kotlin, then those new overloaded methods basically appear out of the blue for the Kotlin perspective and allow for a more idiomatic usage with Kotlin. It's a really nice model. The Kotlin extension model is one of the best features for integrators like us in Kotlin. A very clean and enormously useful extension model that we are making good use of here. So, and now, last for this section, we also have a data class binding revision in Spring Framework 5, where whenever we're binding incoming parameters to a particular target class, think about Spring MVC declaring a particular object type with a few setter methods, and we're binding incoming parameters to them. That sort of thing is data binding in Spring. This is significantly smarter now in Spring Framework 5. If the target class does not have a default constructor, then we assume that it's not actually a Java bean, doesn't have to be populated through setters, but rather wants to be populated through the constructor. It's a design convention. It's basically a Java class with a single primary constructor, accepting all its parameters, basically all its attributes through constructor arguments, storing them, having getters, equals hashcode, toString implementation, probably being immutable. So everything final and not mutable. Makes a lot of sense to use those in particular for parameter objects. This is a convention that you can follow in Java, but it's even nicer with Kotlin. So the data class person val name string val age int is a full Kotlin data class definition. You're basically specifying sort of the constructor, and Kotlin generates the fields and the accessors and equals hashcode toString from it. A similar convention is available. That's the @data public class person example. A similar convention is available in Lombok, the infamous Lombok tool, basically used as a sort of Java extension. So here the convention is a little different in how you express yourself. You declare the fields, and Lombok generates the corresponding constructor accessors equals hashcode toString. It all results in the same convention at runtime, and Spring Framework 5 happily accepts that convention by default now without any extra configuration. All right, let's move on. So the Java 8 baseline is a very important enabler. And as outlined here, it's not just for some rather obvious features that we want to enable, in particular in your code. There's also a little bit more subtlety behind what we can do and how we can do it now that we have a Java 8 baseline. Personally, I'm super happy that that baseline is now basically industry standard. We've never had a situation in the Java ecosystem where so many people were on the same Java generation. I mean, it's basically, these days, it's somewhere between 80 and 90% of us are basically on Java 8. Hardly anybody on 7 and 6, hardly anybody on 9, 10, and 11. And that's exactly what we are going into right now. So what about 9, 10, and 11? It's great to have 8, right? But shouldn't we also have an upgrade plan beyond 8? Yes, we should. 9 and 10 are sort of intermediate releases in Java's new release cadence. You've probably heard about it in many shapes and forms. They are basically alive for half a year, immediately superseded when the next one goes out. JDK 9 is not a long-term support release, so it has already been superseded by JDK 10 in March. Oh, it's just about a year ago, right, that JDK 9 came along, but it's already superseded since March. And even JDK 10 is already superseded by JDK 11, which we got just, about 2 months ago. So JDK 11 is declared as a long-term support release, which also explains the title of this talk. It's what we primarily focus on. It's 8 as a long-term support release, and 11. And 11, of course, accumulates all the language and API improvements that 9 and 10 delivered, and comes with a few improvements of its own in 11. So from the perspective of the JDK as it presents itself today in its 11 form, this is a heavily refactored version of the JDK, right? It comes with JDK 9's revision for the module system. It actually removed several modules in 11. So some of the modules like JackSpeed, JacksWS that were marked as deprecated in 9 are now removed in 11. This can be a significantly different layout than what we're used to from Java 8. As an important enabler, there's a new tool called JLink, allowing you to build custom runtime environments. Nothing too fancy. It's basically a sort of JRE with a selection of modules that you're generating an image for most purposes. You could add a few standard modules from externally obtained modules and add it to your image if you wanted to, but the primary purpose is just a smaller, tighter standard runtime environment, really. From a framework perspective, we have to revisit our assumptions. Basically, what is reliably present in a particular Java runtime environment? We used to expect JavaX.annotation or JAXB or all of those things, JNDI, Java util logging. We expected those to always be present, at least since like JDK 1.4 and then since JDK 6 for JavaX annotation and JAXB. So that's not the case, of course, anymore. There can be a very minimal runtime image that we're running our applications on, that Spring is being used on, where there's just a couple of standard modules, Java-based, Java SQL, and so forth, right? But maybe no JNDI, maybe no Java util logging. So let's not make any hard assumptions about this. Fortunately, Spring, of course, predates not only JDK 6, but also JDK 1.4. And in our framework design, we never made hard assumptions about Java util logging or JNDI or JAXB, and not even about common annotations. So from a Spring perspective, this is reasonably straightforward. Other frameworks and libraries out there, commonly used frameworks and libraries, have hard assumptions about those in them. You will have to add well, the same APIs and implementations that you used before, but you have to get them from Maven Central now and manually add them to your build, to your deployment image. So that's the module graph in Java 9. Was already a bit cut off now, so this Java SCE and that stuff on the top here is basically gone. But it's still it's an innumerable number of modules, right? It's not that many modules that we have to deal with here. It's even a little less in Java 11 already. Familiarize yourself with those, and if you're building a custom runtime environment, just find out what you actually need to use for the particular frameworks that you chose, and you can create a significantly minimized runtime environment from a standard OpenJDK distribution using the JLink tool. That's the primary benefit of the module system, from my perspective, from many people's perspective. But you can also go beyond this and choose to use Jigsaw for declaring application modules. This basically means that not only the JVM itself is running in a modularized form internally, you also choose to embrace a form of modularized deployment for your application components. This is not that different in practice. It's basically still a jar file, but it's a jar file with extra metadata. And instead of deploying that jar file to the so-called class path that we're all used to, we can deploy them to the module path. But the module path still takes jar files, essentially. So there's two kinds of modules, a very explicit one with a module info descriptor, which says like, I'm a module of this name, I require those other modules to be present, and in terms of my surface, there's certain packages that I export. That's basically pretty much what you have to express there. There's also a simpler version of a module called an automatic module. No module info descriptor, just a manifest entry that says, if I'm being used on the module path, here's my canonical name. I export all my packages by default, and I don't require anything specific, but I want visibility to whatever else is on the module path. That's basically an automatic module, in essence. In Spring Framework 5, we decided to ship our jars across the Spring portfolio in the meantime as automatic modules for Java 8 compatibility, for other reasons, like we don't have well-defined module names for all of our optional dependencies yet. There's a little bit more behind this. But we're shipping automatic module name manifest entries in our jars. So if you get them from Maven Central, those jars can be used, like Spring Context jar, can be used on the class path or on the module path. It's your choice. If you want to use them on the module path, an application level descriptor could look like this. This would be part of your application module, where you would not only require specific standard modules, you might also require some Spring modules, like spring.jdbc, spring.context, next to, for example, java.sql. We are essentially enabling you to opt into the module system. If you want to embrace the module system for your application deployment units, then our Spring jars, the Spring Framework jars, are happy to participate in such an arrangement along those lines. With a well-defined convention, we export everything by default because historically The class path has everything exported by default. So we're actually quite happy with this arrangement. And even if at some point we switch to module info descriptors that we ship, your experience in using the Spring jars from an application perspective won't be that different. It will be almost the same. We can have additional benefits through implicit dependencies that we bring in that won't be the case all that often, actually, in our analysis. So a few specific notes. If you choose to use the module system, you might care about what exactly your modules are exporting, right? So exporting is essentially a form of public, right? Of externally public. So only exported packages are accessible from other modules. More specifically, the public types in exported packages are accessible to other modules. Public types in a non-exported package are not accessible to other modules. So be aware that there might be many consumers of your modules. There might be somebody just using an API portion of your module, but there might also be somebody bootstrapping your module. The bootstrapping code also needs some public types that it can refer to in order to bootstrap your service, right? So the API service may not be as minimal as you may initially think you can have it. There's an additional notion called openness. So modules can export certain packages. Modules can also declare packages as open, or the entire module as open. Exporting literally just means making the public types in that package accessible to other modules. Opening means deep reflection on the types in that package. So that means if you generally open it or open it to certain other modules, those other modules or all other modules may use reflection to call methods, to access internal fields. This is in particular useful for data binding frameworks, Jackson, Hibernate. In certain scenarios, you may want to open the package also to Spring, or you may declare them as open for usage with Spring, but that's not generally necessary. As long as your Spring configuration, your Spring binding arrangement, your entire use of Spring just refers to public types in your classes, public constructors, public methods. As long as that is the case, there's no need to declare them as open. It's totally sufficient for them to be exported. Only if you want Spring to intentionally want Spring to access non-public parts of your components, then and only then you have to declare them as open. Which is not so unusual after all. So there's a few limitations I already mentioned. The Spring modules come as automatic modules, so it's a runtime dependency resolution. You need to make sure that they basically well-defined arrangement is actually present on the module path. For example, like Spring context can't implicitly bring in Spring code jar. You have to just put it onto the module path. It's not an issue at all in practice. Just be aware that you control the module path just like you did control the class path. And the module path even has a few nice features like validating the arrangement for you, making sure there's no overlap in the packages, making sure it's actually complete on startup, even allowing runtime tools to reflect upon the deployment structure and understand which modules certain packages come from. There's quite a bit of goodness in just the runtime reflection opportunities around Jigsaw here. There's just not many tools out there making use of it yet. So it's your call. Spring jars participate as automatic modules on the module path if you choose to do so. You can't use the Spring jars with JLink at the moment, so if you wanted to include Spring in your runtime JVM image, with JLink that doesn't quite work because JLink wants a full module info descriptor. It wants a full transitive dependency arrangement. I don't see this as very necessary. Just deploy your application jars and the Spring jars with them on a JLink image with the core JDK modules. Not that bad at all. Otherwise, you would really have to have module info descriptors. You could add them manually to the jars. Some people do this. We will ship them at some point, but the primary purpose is not to enable JLink. It's just because we can and because it's a formal declaration of the module dependency. So we will do it at some point, also from a design perspective. Just a note that JLink itself is actually a somewhat simple tool. The native image feature in GraalVM called Substrate, the Substrate VM in particular, native images there are much, much more powerful and with dramatic benefits, basically, coming out of it, whereas JLink just saves a bit of disk space, to put it bluntly. Graal VM has many more benefits coming out of its native image model. Now, you're probably on Java 8 with if you have a Spring-based application on Java 8, there's a few options you immediately have. So the simplest option is forget about the module path. Stay on the class path. Maybe that's not even a choice, right? If you're using Tomcat, War deployment, Spring Boot, embedded deployment, the class path is managed for you. You don't set it up yourself anyway, right? So in most cases, this is not even a question. In any case, just stay on the class path. You'll have a simpler, more immediate, more rewarding upgrade experience. Additionally, consider staying at Java 8 bytecode level. In particular with Java 11, there's known trouble if you compile with target 11, which is the default, of course, in Java C on 11. It produces Java 11's new bytecode format with a different constant representation. There's certain tools, ASM itself, tools embedding ASM, are not able to parse that bytecode format. If you want to keep using tools that can't read the bytecode format, consider just compiling with target 1.8 or leaving your build at target 1.8, which is probably what it says right now, and deploy the outcome on Java 11. You'll get many runtime benefits from just taking a Java 8-based application compiled against Java 8, deploying it to a Java 11 runtime. All the runtime benefits, the garbage collection enhancements, better memory usage, compact strings, all of this is available to you. None of the new language features in 9.10.11, but many of the new runtime features in 9.10.11 are transparently available to Java 8 applications that way. So building against JDK 8, running against JDK 11 is actually a quite sane transition strategy. So this is roughly where we're at. Spring Framework 5.0 is already out for a year, came with the initial support. We rolled JDK 10 support into it just because we could, and it set all the themes, the functional theme, the reactive web stack, which we haven't been talking about today, but there's a talk about it tomorrow, as mentioned. In Spring Framework 5.1, we primarily focused on the JDK 11 story. So from a Spring perspective, target 11 is perfectly fine. Spring is happily going to deal with Java 11 bytecode everywhere. It's primarily other frameworks, other tools, other libraries, other build tools that you're using that might not be quite ready for Java 11 bytecode yet. Spring certainly is, so it's your choice. Choose to use it with JDK 8, with 11, but 1.8 level, or with 11 and 11 level. It's your call. We have some initial compatibility with Graal VM in there already. Graal is not final yet. It's at RC10 in the meantime, so it's in its extended release candidate phase. We have been doing quite a few measures already, so that an out-of-the-box experience with certain kinds of Spring applications on Graal can be perfectly smooth. This is not the end of the line yet. More extensive kind of complete Graal VM support with its GA form will follow in Spring Framework 5.2, mid next year. So we are up to date with the latest releases, ASM 7 in particular, out there in the ecosystem. The ASM is something we repackage like Obgensis and zglib, so the version that we ship really matters. In our next iteration, we aim for a delivery in June. So Spring Framework 5.2 will probably have a release candidate even in like mid-May, GA towards the end of June. JDK 12 is a topic. I admit it's not that much of a topic because ASM 7 is already ready for JDK 12 bytecode level. And there's not that much non-experimental stuff coming in JDK 12. So we'll make sure that everything runs smoothly, but it's not really a major theme in its own. The aforementioned Graal VM story is a huge one. We have Kotlin 1.3 the coroutines that are now a production level feature in Kotlin that we're going to embrace and have out of the box conventions for, even at the core framework level. There's a few other releases coming, like Hibernate 5.4. We have some other research topics that are going to materialize in the same time frame, like R2DBC for reactive database access, RSocket for basically a reactive messaging arrangement. Both of those are expected to have the core support also shipping in Spring Framework 5.2, even if their full extent is going to materialize, in particular at Spring Boot and in other projects in the Spring portfolio, as a forward note kind of to what's happening in the reactive space. Well, so much for the purposes of this presentation. That's the end of the tour that I have for you today. This was a rather deep dive about certain areas at the core framework level, the Java 8 baseline, and in particular the way we're dealing with the new releases beyond 8, JDK 11 in particular. I hope that there was quite a bit in it that you can make some practical use of. We are empowering you to make very up-to-date decisions in terms of the infrastructure that you're using. Please make use of that power and consider not only an upgrade to like Spring Framework 5.1 and Boot 2.1, but also in particular an upgrade to JDK 11. Trying to understand what it takes to upgrade your applications to 11 is already a huge start. Doesn't mean you have to ship it right now. Just know where you're at with it. All right. Thanks for your attention. If there are any questions, please just come up to the stage. I'm happy to take them and enjoy the rest of the show.